The ability to make a decision and live in a social environment are incredible advantages for any organism. Decision making allows an organism to discriminate between multiple options and predict the most advantageous option amidst potential costs that come with each one. By living in a social setting, organisms can work with each other to accomplish these decisions. For example, take the most dominant species on the planet, hummus. We are able to make complex decisions to find the best one and work together to accomplish far more than we could alone. In the natural world, ants are somewhat similar to humans. Like humans, they are widespread, found all over the world, and are effective competitors in their environments. They are able to coordinate wars on enemy colonies, collect food, or designate ants to specific jobs. While they are social organisms, there's evidence of ants being able to make individual decisions. A special type of ant species are slave-making ants. They are brood parasites that invade the nests of usually weaker prey colonies, kidnapping young ants' pupae and taking them back, raising them as their own for them to feed them, forage, and do worker-related actions. Slave-making ants are, really incompetent on their own, so they need to conduct several successful raids to actually be able to feed themselves and such. When raiding, there are two main risks: high mortality rates and potential lack of payoff of pupae. If a target colony doesn't actually have pupae, precious time and life is wasted. A colony that has a lot of workers around would most likely mean that there are greater amounts of pupae. However, such a large colony would be more difficult to invade and risk more deaths. Researchers were interested in whether slave-making ants show discrimination in their attack based on how many workers they saw at a potential target slave colony. The researchers predicted that the amount of workers present in a slave colony, T. longispinosus, T. longispinosus, would influence whether or not a slave-making species, Protomagnathus americanus, would decide to invade. 159 colonies of Protomagnathus americanus, the slave-making species, and 415 colonies of T. longispinosus, the slave maker's target species, were collected from the same geographical location. Their demographic breakdowns were recorded in the number of workers and the number of pupae. Two target colonies and one slave-making colony were placed in a Y-shaped container. The researchers studied which target colony the scout parenthesis S from slave-making colony chose to attack, and took into consideration the amount of workers and pupae the chosen colony had. However, very few scouts actually found both slave colonies. So the researchers modified their parameters to whether or not a scout chose to attack after coming across just one colony. The researchers found that slave-making scouts attack colonies with greater amounts of workers more frequently. In this figure, slave-making colonies attacked colonies with greater amounts of workers 17 times compared to attacking colonies containing fewer workers only 6 times. The researchers also found that the number of pupae in the slave colonies had no effect on the decision-making of ants. As the researchers recorded, slave-making colonies attacked 13 colonies with fewer pupae compared to the 9 more pupae colonies, suggesting that the actual number of pupae had little effect on decision-making. A positive correlation was found between the number of workers and actual attacks with a low p-value of 0.037. The data supports the researchers' hypothesis that ants would vet colonies based on how many workers were present. The results offer support that slave-making colonies will discriminate colonies based on how many workers they have, and that they favor colonies with higher amounts of workers, as seen in the positive correlation between amount of target workers and actual attacks, with a low p-value to boot. As the actual amount of pupae proved to be inconsequential in the ants' decision to attack, perhaps ants know the association between the amount of workers and the amount of pupae. More workers usually indicating more pupae. Perhaps these ants have some concept of risk versus reward, as attacking a more dangerous area could potentially yield a bigger payoff. This would mean that a smaller number of raids are needed. Perhaps ants are capable of higher levels of processing and depth of association than we knew before. What do you guys think? Do 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 do. Do 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 do